It's Wednesday, November 5th, 2025, and today's topic is Earth. So the challenge is to use classical elements, or rather, this is the first of four challenges focused on the classical elements. The first element being Earth. So the focus is on the tangible and grounded. Map landforms, geology, soil, agriculture, elevation, or anything solid beneath your feet. So I chose to map soil today because I didn't have a lot of time. This is a quick one. And captures kind of an interesting observation that I'd like to dig into further regarding the soil corrosivity dataset coming from Esri's Living Atlas of the World. So we have soil corrosivity potential for steel and concrete layers available. These are image services, so each pixel has a value for the level of corrosivity for these materials based on the soil. And it's a pretty in-depth methodology that draws from the Natural Resources Conservation Service data source, ultimately rolling up to the USDA and the federal government. But what I observed is that these corrosivity rates at state boundaries seem to change abruptly. So, physical geography, the surface of the earth, and political geography, the boundaries of states, very often do not come together so neatly. So the assumption here is that something in the way that these corrosivity rates are derived highlights a difference in methodology or temporal data acquisition between the two states. So the static map represents a screenshot, kind of a point in time posing a question. But if I jump into the ArcGIS project here, we can see a couple other instances of this phenomenon occurring. So if I continue down, scroll out a little bit, and just take a look at the entire state of New Jersey, we're going to see this information draw onto the map. Now the most pronounced boundary change is still right here, that area that I focused on before. But if I turn off the steel corrosivity and just take a look at the concrete corrosivity rates, we see another interesting pattern develop. First interesting thing is that if I zoom back into that area, the concrete corrosivity rates seamlessly blend across the New York, New Jersey border in that area, but then in the mountainous area seems again to form that sharp boundary. So in order to explore the actual polygons that these rasters are derived from, what I would need to do is use the polygon data for these soil map units, and that's what this USA SSURGO downloader app is intended to do. This is intended to make it easy to download these large and very data-rich map soil unit data. So that is a future topic for me, maybe even part of this 30-day map challenge. So let's just take a quick look at the corrosion, because it's, again, a really interesting breakdown between New Jersey and Pennsylvania. See here? The state of New Jersey, the entire southern part of the state of New Jersey, is considered to be high corrosivity for concrete pipes, maybe even concrete road surfaces, but Pennsylvania is not. One thing I've observed is there seem to be a lot more concrete road and highway services in the state of Pennsylvania as opposed to the state of New Jersey. So maybe this is accurate, but then we can see here, look at the Delaware state boundary. We can see it pretty obviously there. So this is something to dig into. First off, because corrosivity rates of soil is incredibly important as the nation's infrastructure continues to age, especially in this East Coast, Eastern Seaboard, highly developed, aging part of the country. We really want to know what soils are more corrosive to steel and concrete pipe materials. And we need good GIS data to base our analysis on. Or at least a data set that doesn't have state boundaries all over it that could be called out in any kind of demonstration situation. So I'm going to look into this a little further, and hopefully provide an update in the form of a map as part of the 30-day map challenge. But the beauty of this event is that really it's not too demanding. It's not a competition. So pose a question, grab a screenshot, check the box, and that will do it for today. Hope you got something out of this. Thanks for your time. I'll see you tomorrow, where the topic is dimensions. Thanks for your time.